The last bit we're going to do today is actually a really easy little formula that isn't as useful as it used to be, since calculators can do most of this work now for us anyway, but when you get to calculus, you will use this formula just a little bit, so it's good to have it. Okay, we're going to solve this equation, but in order to do it, we're going to turn it from a log to an exponential. We kind of had this skill the other week. We can say that if x is equal to the log base b of some number n, that means that b raised to the x power is equal to n. That's what those two mean. That's the same thing. So we can solve this equation using our common logs the way we've been doing so far today. Take the log of both sides. The log of b to the x equals the log of n. And then pull the exponent down. That's the reason why the common log helps. So x times log of b equals log of n, which means that x is equal to, if we divide both sides by log base b, sorry, not base b, log of b, that means x is equal to log of n divided by log of b. Well, remember, we started by saying that x is equal to log base b of n, and we finished by saying that x is equal to log of n divided by log of b. Well, that means that those two things must be the same thing. Log base b of any number is equal to the log of that number divided by the log of the base. And this is what we call the change of base formula. It allows us to change any log of any base into common logs. So if we look at number 18 on the bottom there, log base 4 of 25, I don't know off the top of my head what exponent you need to make a 4 become a 25. It's somewhere between 2 and 3, because 25 is somewhere between 16 and 64. But what we can do is turn that into common logs and write that as the log of the argument divided by the log of the base. And so these two things are equivalent with what we call the change of base formula. One way you can see maybe it's a little bit useful is both log of 25 and log of 4 can be simplified, because 25 is 5 squared and 4 is 2 squared. So we could write both of those as 2 times the log of the square root there over 2 times the log of 2. I just turned that 25 into 5 squared and pulled down the 2. And then those 2's will cancel out. So log base 4 of 25 is the same thing as the log of 5 over log of 2. And that's a good way to see that change of base kind of helps you get to equations that you wouldn't have guessed, that log base 4 of 25 is the same thing as log base 2 of 5. Probably wouldn't have guessed that, but it's true. And just one last quick example. We'll do the last one here. This one's not as interesting, but we can just turn log base 7 of 34 into log of 34 divided by log of 7. Just two ways of writing the same thing.